Okay, last video, the 2013 multiple choice questions. Okay, same old, here we go. We're looking for a maximum. Okay, the maximum would be when the derivative is 0 or undefined and changes from positive to negative. So we're looking for derivative is 0. We're looking for a derivative on a derivative graph. So they match. If they match, we're looking for a height of 0 that changes from above to below. So visualize what that is. On an x-intercept, we need like an x-intercept where the height goes from above to below. We're looking for something like that, above to below. All right, keep that in mind. That's what we're looking for. Then put this in your calculator and look for above to below, x-intercepts, okay? And if you need to, change the window. Here we go, switching to the calculator. Okay, plugged that into y equals. Going to graph it now. See if I need to change the window. We were looking for above to below, so I can see the answer is right here. But there could be more than one answer because I don't have the window correct. So I need to make sure I have the full number of answers. So, got to change the window because remember, it said between negative 2.5 and positive 2.5. I think I got to double check. So yes, the window should go from negative 2.5 to positive 2.5. So there could be another answer that I can't quite see. So I'm going to change my window. Window, negative 2.5 to positive 2.5. Remember what you're trying to find again. We're looking for x-intercepts where it goes from above to below. Okay, x-intercepts from above to below, and there is only one. And since there's only one, it has to be choice E. Okay, moving on to number 85. Okay, number 85 is a tricky one for a lot of people. All right, read it slowly, read it more than once. Here we go. A particle moves along the x-axis. Time is involved, can't have negative time. The position is given. That's the position. What is the velocity at the first instance when the particle's at the origin? So I'm going to be finding velocity at some point. Okay, but what is that point? It's the time when the position is at the origin. So in other words, we want to know when does this position have a position of 0? So I need to figure out when does this equal 0. Now I can honestly do that by hand. I don't need my calculator. You could use your calculator, but it might confuse you more. We'll see. Either way, I can solve it by hand or I can use my calculator. Now, by hand, you can think, when does cosine without this part cover this part up? When does cosine equal 0? What's the first time that would happen? That would be at pi over 2. So then, uncover that up. That means the square root of t equals pi over 2. Square both sides, and you'll get t equals pi squared over 4. And that's what you're going to plug in right here. Okay? So now we're finding the velocity at pi squared over 4. Well, now you could still do this by hand up to a point. You could find the velocity equation by doing this derivative, but this is a calculator problem, and we're doing the derivative at a point. So you can just do n derive of this evaluated at this point. Okay, so I'm going to do the derivative of this, evaluated at pi squared over 4. Okay, I'm going to switch to my calculator. We're doing the derivative of this at pi squared over 4. That's option 1 anyway for solving it this way. Okay, so on your regular computation screen, I'm doing n derive, math 8. Math 8. Always with respect to x. Okay, I'm going to plug in the function cosine square root t. Cosine square root of t, but they don't know the difference between a t and an x. And I want that evaluated at, what did we say that was? Pi squared over 4. So remember where the fraction button is? Alpha y equals option 1. And we want to put pi squared, believe it or not, second pi squared over 4. There you go. That's one way we could solve this problem. There's another option too. I'll show you in a minute. So I get negative 0.318. So option C is my answer. But again, that's just one way of doing this. So I'm going to circle that, and then I'm going to do it again another way, just in case you did it differently. Okay, same problem, option 2. We're still going to need to find, we still want to do the derivative. Sorry, don't know what I just did. Okay, we still want to do the derivative, so we still know we're going to be doing n derive, and where we want that derivative to occur, remember we said it was pi squared over 4, but if you didn't want to calculate that by hand, we're still looking for when this guy equaled 0. Well, you can graph this and get the decimal approximation of when that happens. So we're going to graph this, look for when it has a height of 0, the first time that's positive, because it's greater than 0. So you can get the decimal approximation, and then you can do n derive of that decimal. Same way, okay? The only difference is I'm going to solve this with my calculator instead of solving it by hand. Okay, so let me show you that one just in case you did it that way. So I'm going to graph this and look at the first time that it has a position of 0, a height of 0. Don't confuse that with looking at where it actually hits the origin necessarily. When does this have a position of 0 the first time? Got to change my window. So I changed my window to go from 0 to 10 because time can't be negative. And I'm looking for the first time that this has a height of 0. And that's that x-intercept. And then you find your x-intercept like usual. Okay, again, we're looking for that x-intercept. We're looking for this point here. Okay, because that's when the position is 0, because that's when the height is 0. And that x-intercept is going to be the same as pi squared over 4. This is instead of doing it by hand. Okay, so second calc, x-intercept is 0. Get to the left of it or type a number to the left of it. Then get to the right of it or type a number to the right of it and hit enter. And that's the value, 2.467, that we're going to plug into n derive. Okay? You can check and see, though, if that number is the same as pi squared over 4, but it better be. So remember, we want that number for x. So when we quit, I'm going to hit x so that that number shows up again. If you want to prove to yourself that that's the same as pi squared over 4, you can. Pi squared over 4 better be the same value. Yeehaw! So now you just do the same thing and derive at that point, okay? Math 8. Always with respect to x. I can use y1 because it's still graphed there instead of typing it back in. And evaluate it at, my value of x was my last answer. Second answer. Should get the same answer, and we do. Option C. Okay, last one. Relative extrema. Relative extrema, that means maxes and mins. Okay, justify first. Maxes and mins, that's when the derivative is 0 and changes from positive to negative or negative to positive, since we want maxes and mins. So we're looking for a derivative of 0 on a derivative graph. So we're looking for a height of 0. So we're looking for x-intercepts, and they can go from above to below or below to above, but they have to change either way. So that's what you want to keep in your mind right now. That's what we're looking for. We're going to graph this and look for this type of x-intercept And we're going to make our window go from -4 to 2. Okay? Switching to the calculator. Okay, I plugged it all into my y equals screen just the way it looks. Now I'm going to change my window to go from -4 to 2. And remind myself that I'm looking for x-intercepts that change signs from above to below or below to above. How many of them are there? This is tricky, tricky, tricky. All right, so here's the deal. I may not be able to quite see that first one. So I can see we definitely have one here. We definitely have one here, one here, one here. But over here, I can't tell if that's 1 or 2 or none. Okay, it could go up and back down and I just can't quite see it. Okay, or it could touch and come back down. So I'm really going to have to zoom in on that point. Okay, and just that point. So right now we know we have 1, 2, 3, 4, and this is all that's in question. So we're going to zoom in on that spot right there. Okay, to zoom in that spot, you're going to hit zoom 2, that's zoom in. Then move your cursor over to that spot. Okay, arrow on over. And now when this blows up, remember we want to see if there's 1 or 2 or no x-intercepts here, okay? Zooming in on that spot at about -3-ish, hit enter. To me, it looks like it crosses twice there. Okay, I could zoom in again if I wanted to, but I'm pretty sure that that's going to cross twice. Enter. There you go. Definitely that's 2 more. So putting it all together, how many did that make it? Pretty sure that made it 6. I'll go back to the original Zoom screen just to be sure, but I'm pretty sure your answer here is 6. So choice E. Hopefully this got a little easier by the time you got to the end. I hope the videos helped. I know in the beginning, like the first 3, it's really difficult, very confusing. If that's the case, go back, watch the videos, and kind of start over. You can see I can find enough of these problems each year that you really, really, really have to be good at using your calculators. You got to use them every day and get efficient, fast, and know the best route right away. Hope you're doing well. Thanks, guys. Bye.